Hi everyone, today we're going to be talking about solving quadratics by square roots. Our objectives for today are that students will be able to simplify radicals and solve quadratic equations by square roots. Let's get started. Alright, a little Algebra 1 review on radicals. We also went over this on the very first day of this chapter. It was our warm-up, and I kind of gave you guys a little review on radicals. But just to remind everybody, a radical is any expression with a square root, cube root, fourth root, etc. And the radical symbol looks like this. Alright, and if we wanted to list out the first 20 perfect squares, hopefully you can recall that perfect squares are anytime we take a number and square it. So the perfect square of 1 squared would be 1, right? 2 squared is 4, so 4 is a perfect square. 3 squared is 9, so 9 is a perfect square. So 1, 4, 9 are the first 3 perfect squares. 1, 4, 9. Now 4 squared gives us 16. 5 squared gives us 25. 6 squared gives us 36. 7 squared gives us 49. 8 squared, 64. 9 squared, 81. 10 squared, 100. 11 squared, 121. 12 squared, 144. 13 squared gives us 169. 14 squared gives us 196. 15 squared, 225. 16 squared, 256. 17 squared gives us 289. 18 squared, 324. 19 squared, 361. And last but not least, 20 squared gives us 400. All right, so being familiar with our perfect squares is very important. Now, when we're simplifying radicals, we have two different cases. The first case is when we have perfect squares, and if we're trying to take the square root of a perfect square, just take the square root of the number. Our second case is when we're taking the square root of non-perfect squares. In that case, we want to break down the radical using the largest perfect square. So we want to look for factors of that number that are perfect squares and break it down. Then take the square root of the perfect square and leave the leftover under the radical. For both cases, if there's a coefficient outside the radical, you need to multiply this with any number that you take out. We always want to simplify the outside by multiplying them together. All right, so let's go through a couple examples of this. All right, so number 1, if we're simplifying this radical, the square root of 49, now 49 is a perfect square, so the square root, oops, I want my pen. The square root of 49 is just 7. However, anytime we're simplifying radicals, we want to be sure to say positive or negative 7, because when we're going back and when we're solving equations and we need to simplify radicals, we need to remember that positive 7 times positive 7 gives us 49, as well as negative 7 times negative 7. So negative 7 squared and positive 7 squared will both give us 49. So therefore, simplifying the square root of 49, both of our solutions are positive and negative 7. Then for number 3, we want to simplify 144, the square root of 144, and we know 144 is a perfect square, so we simply just take the square root of it. That's going to give us positive or negative 12, and we want to multiply that by 2. We have to remember to multiply it by the number on the outside. So our final answer is going to be plus or minus 24. All right, now if you have a problem that looks like number 5, where we're taking the square root of a fraction, what you want to do is break it down so that you're taking the square root of the numerator all over the square root of the denominator. So we would rewrite number 5 as the square root of 1 over the square root of 81. Now 1 and 81 are both perfect squares, so we can take the square root of 1 gives us 1, and the square root of 81 gives us 9. Now we have to remember to put plus or minus on the outside, so simplifying this radical, we get plus or minus 1/9. Then for number 7, 112, that is our second case where 112 is not a perfect square. So what we want to do is look for factors of 112 that are perfect squares. So start listing out the factors of 112. 1 times 112. Neither of those are perfect squares. 2 times 56. Neither of those are perfect squares. 4 times 28. 3 doesn't go into it. 4 times 28, let's see, well, 4 is a perfect square, so we can break it down to 4 times 28. So we break this down to the square root of 4 times the square root of 28. Now we can take the square root of 4 and we get 2, and we remember it's plus or minus 2. And then we've got the square root of 28. Now we can break down the square root of 28 even further because there is a factor of 28 that's a perfect square, and that would be 4 times 7. All right, 4 is a perfect square. So we break the 28 down further and we say square root of 4 times the square root of 7. We can take the square root of 4 and we get 2. We multiply it by the plus or minus 2 on the outside, and we bring down the rad 7. Now we simplify the outside by multiplying 2 and 2 together, so we get plus or minus 4 rad 7. And that would be our simplified radical. If you have any questions on this, please remember to call me over so I can help you. Otherwise, let's move on. Alright, so I want you guys to try number 9 and 11 on your own. Pause your video, give these two a shot, and when you come back, I'll have the answer written on your screen and we'll go through it together. So go ahead and pause your video now. Alright, so for number 9, you should have gotten plus or minus 30 rad 2. How did we get that? So first we want to look for factors of 72 that are perfect squares. We see that 2 times 36, 36 is a perfect square, so those are the factors we want to use. We break down square root of 72 to the square root of 36 times the square root of 2, and then we take the square root of 36. That gives us plus or minus 6. Then we bring down the rad 2. We want to be sure to multiply the 6 times the 5 that's on the outside. We can't forget about it. So we get plus or minus 30 rad 2. Now number 11, we want to look for factors of 250 that are perfect squares. So we start listing out the factors of 250. We get to 10 times 25 and we see that 25 is a perfect square. So we want to break down the square root of 250 to the square root of 25 times the square root of 10. We can take the square root of 25 and we get plus or minus 5, and we bring down the rad 10 because we can't simplify it any further. So we get plus or minus 5 times rad 10, and that is our simplified radical. Alright, so it's really important that you know how to simplify radicals as we move forward. So if you have any questions on this, please call me over so I can help you. Otherwise, let's move on to figuring out how to solve quadratics by square roots. Alright, so we can solve quadratic equations by square roots when quadratic equations are in the form ax squared plus c equals 0. So if our quadratic equation is in this form, where we have ax squared plus c equals 0, so we have no bx, then we can use what's called the square root property to solve. So what we would say is if x squared equals n, what we can do is take the square root of both sides, so then we can say that x equals plus or minus the square root of n. Alright, and that would be the square root property. So our first step is to isolate the x squared. Then we want to take the square root of both sides and simplify the radical. Always place the plus or minus symbol to indicate both answers because we have to remember that it's plus or minus our solution. Alright, so let's see a couple examples of this. Alright, so number 1, this is in the form ax squared plus c equals 0, right? So we can use the square root property to solve this. Now the first thing we want to do is isolate the x squared. So we want to add 64 to both sides, alright, because we want to get the x squared by itself. Cancels out on the left and we're left with x squared equals 64. Then we want to take the square root of both sides, because if we take the square root of x squared, those are inverse operations. Squaring something and taking the square root are inverse operations. They're opposites, just like addition and subtraction, multiplication and division. So if we take the square root of x squared, it cancels out the squared, so we're just left with x. And the square root of 64 is 8, but we have to remember to put the plus or minus symbol after it. So our solution, or before it. So our solution is x equals, we place it in a solution set and we say plus or minus 8. Alright, and we just solved this quadratic equation using the square root property. Alright, number 3. Number 3 is also in the form ax squared plus c equals 0 if we can move things around, all right? So the first thing we want to do is isolate the x squared, all right? So first thing we want to do is subtract 5. That cancels out over here. We're left with 81x squared equals 16. Divide both sides by 81, and we're left with x squared equals 16 over 81. Now we want to take the square root of both sides, so we're left with x equals plus or minus the square root of 16 over 81. Now we know we can break this down, right? When we were practicing simplifying radicals, anytime we're taking the square root of a fraction, break it down to be the square root of the numerator over the square root of the denominator. So the square root of 16 is 4, square root of 81 is 9, so our solution is plus or minus 4 over 9. All right, we put it in braces, and that is our solution. If you have any questions on this, please be sure to call me over so I can help you. Otherwise, let's move on to a couple more examples. All right, number 5, this is in the form ax squared plus c equals 0. All right, even though it doesn't equal 0, we can move everything to one side so that it's equal to a number, okay? So what we want to do is first isolate x squared, so we add 9 to both sides. We get 2x squared equals 64. We're trying to isolate x squared, so we want to divide both sides by 2, and we get x squared equals 32. Now, to isolate that x, we want to take the square root of both sides, so we get that x equals plus or minus square root of 32. Now we want to write the square root of 32 in simplest radical form. All right, so we have to simplify that radical. So we want to look for factors of 32 that are perfect squares. 1 times 32, 2 times 16. Oh, would you look at that? 16 is a perfect square. So we can break this down. We can say the square root of 16 times the square root of 2. Square root of 16 gives us 4. We bring down the rad 2. We remember to put the plus or minus in front, and that is our solution. So our solution is plus or minus 4 rad 2. All right, I know there's a lot of little steps involved in these, so if you have to, remember to rewind and rewatch the example. Call me over so I can help you. Otherwise, let's move on to a few more examples. All right, so I want you guys to try number 7 on your own. So when I say go ahead and pause your video. Try to solve for x on this one using the square root property. When you come back, I'll have the answer written on your screen and we'll go through it together. So go ahead and pause your video now. All right, so you should have gotten that x equals plus or minus 3 rad 3. Now, how did we get that? First thing we want to do is isolate that x squared. So we want to first subtract 4 from both sides, divide by negative 3, and we get that x squared equals 27. Now, to get x by itself, we have to do the opposite of squaring, which is take the square root. So we take the square root of both sides, and we get that x equals plus or minus square root of 27. Now we have to simplify the square root of 27, so we want to look for factors of 27 that are perfect squares. So 3 times 9, we know 9 is a perfect square, so break down the square root of 27 to the square root of 9 times the square root of 3. We take the square root of 9 and we get 3. We remember to bring down the plus or minus, and we leave rad 3 as it is because we cannot simplify that any further. So our solution, we write it in the braces, because it's a solution set, our solution is plus or minus 3 rad 3. All right, the final example that we're going to do has a fraction in it, so I'm going to do it with you because I don't want you guys to freak out over the fraction. All right, don't be intimidated by the fraction. It's just a fraction. All right, let's do this one together. So it's in the form ax squared plus c equals a number, so we can solve using square root property. So first thing we want to do is isolate the x squared, so we're going to subtract 1 from both sides. We get negative 1/2 x equals negative 40. Now, we want to divide both sides by negative 1/2. Divide both sides by negative 1/2. Now, remember, when we're dealing with fractions, what we're saying here, negative 40 divided by negative 1/2. That is the same as negative 40 over 1 divided by negative 1/2. Now we cannot divide by fractions, so we copy the first one exactly how it is, change the sign from division to multiplication, and flip the second one, all right? So we always multiply by the reciprocal. We cannot divide fractions. So we end up with positive 80, all right? Positive 80 over 1. So therefore we say that x squared equals 80. Now we want to take the square root of both sides, and we get that x equals plus or minus the square root of 80. Now we want to simplify square root of 80, so we want to look for factors of 80 that are perfect squares. 1 times 80, 2 times 40, 3 doesn't go into it, 4 times 20, not perfect squares, 5 times 16. Oh, well, I guess 4 was a perfect square as well, but 16 is better because it's bigger. All right, so if we're using 16, we say the square root of 16 times the square root of 5. And if you used 4, that's fine. You would just have to break it down one more time. All right, so we take the square root of 16 and we get 4. We remember to put the plus or minus on the outside, and we write down the rad 5 because we can't simplify that any further, and that is our solution. We write it in braces because it's our solution set, and we say that x equals plus or minus 4 rad 5. All right, so hopefully you learned a thing or two about simplifying radicals and solving quadratics by square roots today. If you have any questions, please call me over so I can help you. Otherwise, look to the board to see what to do next, and I hope that you have a great day. Bye.